Organic Chemistry Part 2 deals with functional groups, which is an atom or group of atoms that imparts characteristic chemical properties to an organic compound. So we're going to look at different functional groups. The first type of functional group is an alcohol. Alcohol contains the hydroxyl group, the OH group. Methanol is an alcohol, for example. The nomenclature, we're going to find the longest chain that includes the hydroxyl group. And we want the hydroxyl group to have the lowest possible number. So here's an example of an alcohol. I want to find the longest chain with the OH. So the longest chain is a 3-carbon chain. We have a substituent on carbon 2. So we're going to name this substituent just like before, 2-methyl. We have to indicate where the hydroxyl group is at. So 2, and then the 3-carbon chain is prop. So propanol. The suffix for alcohols is OL. Aromatic alcohols are called phenols. So this first molecule here is just called phenol. That takes care of the OH in the naming of it. So it's a benzene ring with an OH group. In this second example, the OH gets carbon 1. So when we number the other groups, we have to number off of that hydroxyl group. So we have substituents on carbons 2, 4, and 6. So we're going to say 2, 4, 6. And those substituents are nitros. So trinitro. And then phenol. Polyols contain more than one hydroxyl group. So in this first example, we have a 2-carbon chain with hydroxyls on carbons 1 and 2. So I would name this 1, 2, ethane, and since there are 2 hydroxyls, diol. 1, 2, ethane diol. In this second example, I have a 3-carbon chain, so that's propane, and there are hydroxyls on all 3 carbons. So I need to indicate they're on carbons 1, 2, and 3. So 1, 2, 3, propane, and since there are 3 hydroxyls, triol. Alcohols can be classified as primary, secondary, or tertiary based on the location of the OH group. A primary alcohol has a hydroxyl group bonded to the carbon with one R group over here. So here's an example of a primary alcohol down here. It's a 4-carbon chain, so it's butanol, and the OH is on carbon 1, so it's 1-butanol. In a secondary alcohol, the carbon with the hydroxyl group is bonded to 2 R groups. That's what makes it secondary. The example down here, we have a 4-carbon chain, which is butanol, but the OH is going to be on carbon 2. So 2-butanol. And then in a tertiary alcohol, the carbon with the hydroxyl group is bonded to 3 R groups. This example here, we have a 3-carbon chain. We have a substituent on carbon 2. This is the same example as the first page, 2-methyl, 2, propanol. 2-methyl 2-propanol. Carboxylic acids are the second functional group, and they have the carboxylic group, which has a C double bond O and then an OH. And we can write that carboxylic group many different ways. This is always a terminal group. It's always on the end of a molecule. Here are some examples of some carboxylic acids. We're going to find the longest chain containing the acid group, and then the suffix is enoic acid. And so in this first example, we're going to start numbering down here. So this is a 4-carbon chain. 4-carbon chain is bute. And since it's got that carboxylic group, it's butanoic acid. The second example, we're going to start numbering here, just a 2-carbon chain. So that's going to be called ethanoic acid because it has the carboxylic group. Now this is also commonly known as acetic acid. So some of these have more than one name. This is the common name, acetic acid. Aldehydes, very similar to carboxylic acids. They have a C double bond O and attached to a hydrogen. This group is always terminal, just like it was with carboxylic acids. When we name these, the suffix is Al. So we're going to start numbering these compounds with the aldehyde group. That's carbon 1. So in this first example, we have a 3-carbon chain, which is prop, and the suffix is Al, so propanal. Second example, we're going to start numbering with the aldehyde group. So we have a 5-carbon chain, but we also have a substituent on carbon 3, so we're going to name the substituent 3-bromo, and then a 5-carbon chain is pentanal. And we don't have to indicate where the aldehyde group is at because it's always on carbon 1. It's a terminal group. Ketones. Ketones contain the carbonyl group, which is the C double bond O, sandwiched between 2 other carbons. The suffix with a ketone is ONE. So we've got a couple examples of some ketones. First example, we have a 3-carbon chain, which is prop. And since we have that carbonyl group, it's propanone. Now I could say 2-propanone because the carbonyl group is on carbon 2. However, if that carbonyl group were moved over to carbon 1, it would be an aldehyde. So we don't have to include the 2 there because it has to be on carbon 2. It cannot be a terminal group or it would be an aldehyde. In the second example, I want to find the longest chain with the carbonyl group. Carbonyl group takes precedence in numbering. So when we number, we're going to go from right to left. We have substituents on carbon 5. So we're going to name those first. 5,5-dimethyl. And then we have a 6-carbon chain, and the carbonyl is on carbon 3. So we have to indicate where the carbonyl group is at. 3, and then hex. Suffix ONE. So 5,5-dimethyl 3-hexanone. Ethers. They contain an oxygen atom sandwiched between 2 other carbons, and we're going to use old-fashioned nomenclature, naming the alkyl groups alphabetically on either side of the oxygen. So here's an example of an ether. The alkyl group over here is methyl. Over here we have propyl. Nomenclature, just put those in alphabetical order. So methyl, propyl, and then ether.